Hi everybody, I hope you're doing well. Let's get started this live on invoices as implemented by the Bolt 11. Let's go. So what I want to do today and in the next few months is to talk about Bolt 11 invoices, how they are implemented in Core Lightning. And we take that opportunity to look at the architecture of Core Lightning and see some details of the implementation. So not only the Bolt 11 implementation of the specs, this part, because this is something so we can jump into the Bolt spec here. So this is the in my editor. That reference of the spec, and we can see that at the end where maybe I don't know authors implementation. I think there is okay. There is an example. No implementation. This is that one. Okay, it's a B. So if you want just an implementation of a Bolt 11 in Python by Rusty Russell, you can check that one. But what I really want to do is to use that Bolt 11 example to help us if we want at some point to look at other parts of this repository. So there are things that we need to do, for instance, how the plugin system is implemented inside the Lightning repository, how the JSON RPC interface is implemented. So there are some of the things that I think are important to know how to navigate, how to work with that, either to understand some specific aspect of the Lightning Network implemented in Core Lightning, or just to fix some issues, or to implement new features. So we'll do that in the several step phases with those slides. And also, from time to time, I will add some other videos on LNroom.live to complement those live, because we can't do everything, and sometimes it's easier for me to do that in a video that I can replay or redo than in a live. So today, what we are going to do, so we can see what we have in that screen. This is we are going to see how to write command in Core Lightning. So how do we write command? We've seen that how to write command in plugins. So the plugin system offers us the possibility to write to declare JSON RPC commands outside of Lightning repository, outside of Lightning D via the Lightning as a plugin system. But also today, what we're going to see is to look at the implementation. So we are going to write three commands: foo, my-invoice, and my-commands. Foo that takes no arguments and return foo barbars. Also, we are going to see how to return the node ID. We are going to see commands that takes argument, like the command invoice that generates invoices. So we're going to look at that command, and also so we're going to see how to take arguments and how to consume the JSON API in Core Lightning. So how to do that. And the last one will be called my commands, which list the commands registered in the JSON RPC interface. So this is what we're going to do. And let's just look at the invoice command. So here we can see that the invoice command take a bunch of arguments. So amonsat, label, and description are required arguments, and then we are other argument. And if we run that command at the command line, so ln-cli is for lightning-cli with a specific lightning repository running on the rec test. So we are going to start it after. We've done that in other videos, so it should be not easy, but it's already something that we've done. So we get that, and at the end of the following month, we are going to see all of those parts that are related to specifically Bolt 11, that part of the protocol. But there's something that that has nothing to do with the protocol, is the JSON RPC interface. So what does happen when we run that at the command line? This is what we are doing is that we can see in the JSON RPC interface is that we are sending that JSON RPC object, so that JSON object with an ID, a JSON RPC. The method is invoice, and the parameters that are given sequentially. In that case, they are sent like that, and we communicate. The Lightning CLI communicates to Lightning D with the Lightning RPC socket. So it sends that JSON RPC request, and some things if done. So Lightning D needs to have some place to say, okay, I want to run invoice, and those are those parameters of invoice, and I want to give back an answer, a JSON RPC answer response. So we are going to see how we define that command inside the Lightning D. So we have that. We've been talking something, and the command, adding a command to Lightning D. Okay, we are going to see that a little bit after, but let's jump into a terminal, run some command lines, compile Lightning D, and do some stuff and modify some files to get what we want to have. So first thing first, we run configure to no. So we are in CLN Live, and now we change directory and we go in the Lightning repository that I'm checked out in the last stable release 23.08.1, so that we really know what piece of the software we are running right now. So we run configure to configure the option to compile our things, and we want to disable because we are not using the Rust plugin, so we don't need that. So after that, we are going to do make clean. In the case, I had some of the thing before done. So let's see. So we do make clean, and now we maybe we can look at the repository. So this is the repository with all those directories, channel D for the daemon channel D, closing D, and we are going today to focus on the thing that happened in Lightning D here. And specifically, so we can see invoice is done in the invoice. We are here in that line, invoice.c. We are also going to look at the command method command, which is called getInfo, which is in peer control, if I'm not wrong. And also at the end, to list all the command line, we are going to add a command in JSON RPC.c. So we are going to touch at those three files today. Go back to the terminal, and now we compile. So the first time, or the two first time in my case, because so right now I'm compiling in in the terminal, but after we run command, and this is going to be compiled in a different buffer in my editor. And the first time, and then the second time with a specific command, we compile everything. But when we are going to change just some parts, some files, only those files are going to be recompiled. So let's go now. What we want, maybe we go back to the directory lightning-d, and in that directory will be build compiled and build some binary, and the binary that we are interested in the lightning-d binary that we are going to run. So here we have what can terminal. It's not done yet. Let's just wait a little bit. No, we can go to the node, and the first thing that we are going to do is to go in the lightning peer control CC. Yes, I know what we can do while this is. We can look at how do we add a command to lightning-d. How do they are defined and built. So we can look at the getinfo example in lightning-d.peer, but basically what we have to declare, we have to define first a function. Here, this is exactly how it is done for getinfo. So a function that returns a pointer to a command result. This is the actual function that pass the parameters of the command and that return what the calculation that we want. Not in every case. For instance, in invoice, this is given to we have to call a command in a plugin, so it's done differently, but it's not what we do today. Today we do the simple thing. So we define one, then we have to define a JSON command. We're going to see what is a JSON command that we have here, and we pass to the auto data statement that we are here the address of the command that we use. And in when we declare that command getinfo command, that struct, the first field is the name of that command, and the third field is a JSON underscore getinfo function that we have just above. And yes, autodata is there to declare, to register all the commands defined in the source code before running the main function. So I think I will make a video about just that part that I found really interesting. So let's go back to the terminal. It's almost done, but let's go in the lightning-d and look at autodata. So we can see at the bottom that I'm doing a grep search of autodata in the repository with an open parenthesis. And here we see that we have 117 hits of autodata. And this is all the functions that are the commands that are collected before. Okay, they are collected on at compile time, and they are run before lightning-d start. So there is a specific map. I think it's called type map for the type JSON command that have an array of all the commands that we have. So they are all in lightning-d wallet and everything. So we can see for getinfo, where is the getinfo? We have the light getinfo. Also, we have the invoice here, which is defined. and we are doing something that is not same thing at the help command, but in some way the help command lists the command with the description. So we are going to do something similar. Let's go back to the terminal. This is now compiled. I will drink a little bit. I talk a lot, and we almost done nothing. But after it's when we describe what we are going to do, it's faster. So first thing, as we've done in many live on the videos, we source the startup reg test script, and we see as we've compiled right now Lightning D, we have in the directory Lightning D the binary Lightning D that we are going to run, and we are using that one to start right now two Lightning nodes start ln. So we start two Lightning nodes running on reg test, and normally it should work. It takes not a lot of time. So two Lightning nodes, but we care only with the node 1, which add the alias L1-CLI. So let's see that. So alias L1-CLI, which is the alias. And now what do we do? Okay, let's just generate an invoice. No, wait a minute. L1 CLI. Okay, get info. Wait a minute. What is exactly what I want to demonstrate right now? Okay, let's just get info. So the node is running, everything is fine, and now what? Let's call CLI invoice and maybe 10,000 millisat, and we want one label that we call label 1, description 1. Okay, so we have that. Okay, so we run a command. I think that you already know how to run those commands, and now we are going to write our first command. And to do that, we can go in first, say peer control. Peer control. So we are in that file. And we can see we have a bunch of things. Many things are functions are defined, and we can see at some point we see some auto data. So here we have some functions that are defined. So we are at peer, this one, and let's go to it is here. So we have the JSON get info. And we can do something like that, just narrow on that part of the buffer. It's not exactly that. Okay, so we narrow just on this one. So this is what we've seen. So we define a command recent JSON get info. We have the command. We have the buffer on those things that are that hold some information, but we don't need to know everything about that. And here, at some point, we define we collect the parameters. But in that case, we don't take any parameters. So to that, we use the function param. Then we start a stream. This is how it works. So we start a stream response, and at some point we add some stuff in this, and at the end we return command success on that one. Let's look at that part now. How do we define that JSON command? So we can look at the definition of that struct, and that take a name, a category, the function that we call when we find that we want to run that function, if it's deprecated, and the verbose description. So we go back. Now, the name, this is getting for the category utility, and we can see in the note that, okay, we have the categories where those categories become challenge network developers, and the plugin can also set whatever they want, and at the end we are going to set also what we want. Let's go back to peer control and the description, and now we can see here the get info that is here. So we are going to take that that command, change, modify it, and get what we want. So something that the two files that are important is to write those commands are command JSON stream. So the stream that we construct in when we call the command. So we construct the JSON, and we have also the command /JSON param. This is how we pass the parameter of the command. So if they are recorded or if they are optional, or if we want some definition. So let's go back here, and now we are going to write something, and that should go maybe a little bit faster for that part. CLN live. To see where we are. We copy paste all of this, and now we are going to narrow only on that part. If we just recompile that, this will compile, but we're going to have a problem, which is that we can't define commands with two commands with the same name, and this is also what we are going to change right now. The get info command. What we want to try now, so let's go back to our note. We go at the top, and we see we're going to do all those items in order. So we want a command that we call foo, that takes no argument, okay, and that return an object with one field name, which is foo, and its value is another object with field name bar and value baz. So this is what we want to accomplish now, and we call it foo. So we are going to it's a foo command, auto data. The name we give it is foo. And then we call it, we let, this is a category. So let's put it in developer. And just CLN live, number 17 for the description. Foo. Okay. And we might do something like that. Up. And we save. Another thing, we are using JSON get info, but this is no longer the one that we want. We want to use maybe something. So we see this is that function that we defined on top that return a pointer to comment result. So let's call it JSON foo. So now we have that, and we should be able to compile and to run that one, which will return exactly the same thing as get info. So we are running this in the editor, and we see at the top, this is the command that we are running, make -j for. So for the first time in the editor, we take, it compiles a bunch of files, but after it will compile only 6 to 10 files. So let's wait a little bit. maybe we can go in the terminal, and what we want to do now is we have to stop the node and to restart with the new binary. L1 CLI, we stop the node. Okay, so the node has been stopped. And to restart it, let's see, we have the alias before that one. Okay, so we are going to write an alias right now. So at the end, L1 CLI, and we want to run that with --daemon. And this is not Lightning CLI, but a Lightning D, because we want to start Lightning D again. And let's call it the alias L1 start. So normally we are going to be able to use it. The compilation is almost done, but we have to wait before we run that. Okay, so half an hour, and we've almost done nothing, but nothing. I mean, I don't want to say we've done nothing. It's just that we haven't run a code that we wrote so far, but we've seen some stuff. So we've seen autodata. Maybe we can go back to the node to see this is what we want to do, and maybe this is better to put that in big to see what we are doing. So we are doing those three things. Okay, this is the three things that we modify today, and right now we are doing that in the peer console _console -c file. Compilation finished. Okay, so now let's go back to the terminal. L1, because we stopped the node, so we can start it. Seems to work fine. And now we can call the function that we just defined foo, and let's see if it works. Yes. So we see, huh? So we've called foo, and we get exactly the getInfo answer normal, because we just changed some name. Okay. Now let's go back to peer control, and there are a bunch of things that we need and others that we don't need. So first, we don't need all those things that are added in information. The important part for the parameter is that one, meaning that if we pass some, let's continue. Then we are going to add a string. So maybe we don't, the node ID we want it, because if we go to the node here, after we want to modify foo to use the node ID, but we don't need it right now, but we keep it. We want to add a string, so we keep that part, but we are going to change it after. And now we removed almost everything. I thought about how to present what we are going to, what we are doing, and we could have write this as if we know exactly how to write it. But I think that there's really what we do when we write those kind of things, and there is many already examples in the code. The best way is to copy some part that we are interested in and that do almost the stuff that we want to do, and then we can have something else. So the parameter takes a command, takes a buffer, takes the params, and then after it takes a variable number of arguments and end with null. So this is at that place after where we're going to use some other macro to require the argument, to pass them, and to set a variable to use them. So this is done after. If something fails in the param, in that one, we return command param failed directly. Let's look a little bit the param where that function is defined. So it is defined. So you can see in the mod line in green at the bottom, on the left, we are in command slash JSON underscore param, and that function is defined here. So we see parse the JSON token, and in that file there is many other functions that we might want to use. So function or macro. So we see here we have a preg that we're going to use, and also p opt for an option argument. So this is an important file. If we need something to do, we go there, and maybe there is already something, a function that is or a macro or a data structure that already exists. And this is what I like with project that exists for many years, that there already a way to do the things, and so there is already maybe good interfaces and good utilities to do the things that we want to do. So we have the function param. So let's go back. We are back in the peer control files. We have that now. What we have to do is to what is done in that line. So we define a JSON stream, and then we start that JSON stream here. You can say, or we initialize. I don't know how to use that. And after, we have a bunch of functions that we can use, and the first argument of that function is a JSON stream. And what that string is, what those function does is that it's not incrementing, but they modify the stream to create at the end a correct JSON things. And we see now we are using JSON add string, and the first argument will be the name of the field name that we see, and after this is the value that we want to pass. And in that case, we pass the alias of the lightning node. But this is not what we are going to do. And okay, this is the moment that we go to. We jump JSON add string to see its definition, and we see where it is done. It is done within the mod line, so in JSON_stream in the command directory. And here again, we have a lot of functions that we can use. So we can see at the top, helpers for outputting JSON result into a memory, a main buffer, which is the JSON stream that we have. And we see if we have something to do, there is for sure a function that do that. So if we do that with an ID, there will be an ID. If we do that with an inside 64, we have it. With a bool, we have it. So we don't have to write all of the stuff. And for now, what we do, we are back here. We do that with a string. And instead of calling it alias, we called it, what do we call it? So bar, okay, we call it this, bar bars, because we want, remember, we want to do something like that. So first, we are just going to return that things, and then we're going to do a little bit more. So normally, it should go right, and at the end, we use the function command success. We pass it the command that was an argument of the function and the response, which is the JSON string. Let's compile and see if I've done or write something wrong. Normally, we should have something working correctly. And now, not everything is compiling, but just the files that where the changes that we've done depend on. So we have the compilation. We go back to our terminal. Now, what do we want? Stop. We want to start with the new compiled binary, and we want to run L1-CLI foo. Okay. Yes, So we start to have something working and see how the things are working. Let's see what we can do next. Yeah, okay, next. Control. Let's get focused and continue. So, we see here that we kept that thing with the ID, but this is not what we want to do right now. We need to add something because we want to say, okay, object, we want to start an object. So we start an object, take the response JSON stream and the field name. In our case, this is response. And we pass it. What do we pass it? We want the name, which is foo. We have that, and we want to end that object after. So maybe okay, JSON object, and we want to end the object response. We have that, and now we should have that. So we compile and blah blah blah. Everything working fine, and now we go at the top, and what we do, we stop, we start again, okay, and we run foo, and we have the object that we wanted. So we've written a command named foo that takes no argument and that return that object. Nothing fancy here, but hey, we have to start somewhere. So first start. Now we modify it a little bit to return a field, an object with the field name ID with the node ID. So let's go back to peer control, and we have that here. So we can uncomment this one. We no longer need those things. I will just uncomment them, and we have. So now we pass the ID, which is a field name, and we see that the function that we use to modify the JSON stream response is another one. So add node ID. So we don't have to transform the node ID, because if we look up at this one, so ID. So in command we have one field which is called LD, which is the lightning demand state that all everything that is passed into a command, and in that state we have the ID. If we look at that ID, so I just jump into where the lightning D struct is defined, and we see that we have a struct node ID, but node ID is struct with some information. So and we can see at the top, this is a struct, this one, and we can see like that. Yeah, what I wanted to say. Okay, so yes, you see that. So that function take care to transform the node ID struct into something printable that can be rendered in the JSON value of an object. So now we compile again, and in a moment we are going to have. Okay, so let's go back to the terminal, and now we stop again. Okay, so we stop, we start again, we run foo, and we have the node ID. So cool. So at that point we've already seen some interesting stuff that we can go back to peer control files, and we've seen how to define a a command, to add a command to Lightning D. At the end, we have the auto-data that collect all the commands. That's going to collect the command foo command. The foo command is defined here. The name is foo, category developer, and the function responsible for passing the parameters and transforming, not returning, but putting in the JSON stream exact information that we want. This is JSON font that do that, and we add the body. The body here of that function. Okay, so this is the first prototype that we have. Let's go back in the node, and we can say, okay, this is done. Okay, but we wanted to talk about 11 invoices. Okay, yes, but we are not going to talk exactly about the protocol aspect today, because we are we talk about how to add commands, which let us understand how the part are done in that part. So now we are going to go and to look at lightningd/invoice.c, and we are going to look at that command. What does it look like? So let's go, and we want, so this is invoice.c, and we don't want, we want this one in lightning-d. Go at the top, and we can see we include a bunch of files, and here we have some function struct defined. We see that we have a hook, the invoice payment hook here. We have other, that one is the one that we want, but we see auto-data, we are list invoice command, bill invoice, del expired invoice. So we have a bunch of stuff. So when we start to understand what we're doing today, really, we have access on the possibility to read a lot of part of core Lightning. So I don't, to me, it's really an important aspect. So let's take that and just focus on those parts. So we can see, this is really the same thing at a function that return a pointer to command result struct. We define a JSON command, and we pass it to auto-data, which are going to collect those things. And then what is different in that one? Okay, so in that one, first thing that we can see is that part. So we still call parent. That part if developer is no longer compile time stuff. So this no longer exists in the next commit after that, and in the next release that is going to be soon. So we don't care about that things. But yeah, we call param, and we do a bunch of stuff there to set the variables that we've defined a little bit above, and with the name. We have that name, and that name. So this is the three that we've used, and that are required, as we can see here, with that macro. So we are going to use that and see what how it works, on at least how to use it. So when that expand and when param run the function, it will use that function param positive msat to set msatoshi value. So this is the scheme. The same here. Required label, and this use param label to do that. What's cool with that is that we don't have to think too much about those things, because most of them, not this one that is in the same files, and it's specific, because we can specify any, or we don't want it to be null, so there's some things to do. But for instance, this one, or param u64, if we jump in that definition in JSON param.c, so this is what we in the note. This is we talk about that files, or yes, because it's defined in JSON param.h, that we can see those things. And if we want an array, we have param array. We want a boolean. We have the function for boolean. We want a string. We want here a node ID. So to set a variable to a node ID, which was an argument of the function, we can do that. So everything is done for us. When we've said that. One thing that we can see is that we have the info. This is different. Just to tell a little bit first of that invoice command, and then we are going to not to see all the details of that command today, because there are many things that are done. So we do some check. If we didn't give a pre-image, we generate one, we generated hash, we have a secret, and here in the info struct there's a field b1, and we see this is what we are going to see at some point in the next live on the video. So new bulk elements, this is where things are happening. So this is done. We can jump into it. This is done in the command /port11.c. So files of 1355 lines, so 103055. So okay, we do a bunch of stuff, but at the end, okay. So the information at the end, we see we don't return with command succeed. Return with command still pending, because we've done something different there, which is that we need the information of the list incoming command, which is defined in the plugin. I think this is why we have that, and this is what is done there. So we build a request with list incoming, and we pass it the information that we built before, and after we send that request, plugin request send, and the thing unfold after. But this is a bit different, and we're going to see all of those steps. We stay with simple things. So, okay, we have that for that command. We must remember what we are doing. So maybe how do we start with that one? Yes, because we are going to start with that one, because we want to model it a little bit. So what we want to do, we want to write the command my-invoice. It's not really an invoice, but with amount msat as a first argument, and the second description, which is optional, and we want just to return the object with those parameters. Okay, so let's go back to this is in the file invoice. We select everything. We go at the bottom, CLN live. Okay. In comment, we pass to that, and we want now. Okay, so we want to narrow to this, and now we can continue. So the same thing that we did before. We don't need this one. Amount msat. We keep it. We want the description. We kept those those values. We don't set the info. Let's keep the description. The label we don't want. Amount means that. Okay, so let's do that like this. So we have that. So this is almost the same that we did before, with little changes, because we have we take two required parameters, and now let's go maybe almost at the end. Okay, we no longer want command still pending, and we can go into the tier console and take the last part. Okay. Command success. We want something like that. We also are going to need a JSON stream. Okay, so a JSON stream that we put at the top. We have that stream. We check the parameter, and once we've checked the parameter, and we start that stream. It's ancient. I don't know how to say that. A JSON stream. So if we do that, we should have something, but we need to change its name. So no longer JSON invoice as we have right now, but we are going to call it JSON my-invoice. We go back in the JSON command, a new name, my-invoice with a dash. Let's say we stay with payment. This is no yes, JSON my-invoice, and this is my invoice for the description CLN live 17. Don't need that one, and we have to change that also. And maybe we can call it my invoice. So we've done a bunch of modification, and let's see again. So we have those ones that are with response are used in the parameters. If something goes wrong, we fail. We start a response, and we return command success with the command on the response. Perfect. We compiled, and we hope this is going to work. Okay, so this is working. Let's go into here. No, sorry. We are with invoice. This is the one, but we go into the terminal. We stop, and we want to restart with the new binary. And now L1 CLI, my invoice. Let's pass it something because there are two required parameters. So maybe we can do this description, and we return nothing, but at least this is working. So we have something that works, that takes only two arguments. As they are required, maybe we can check that. We removed one, and we see an error, missing required parameter description. Okay, let's continue here and see what we can do. We don't want to have it with two names. We just want one name. Here, we don't need it to be param positive or any. Okay, we just want param, and the one that we want is because they are amount, and we want amount misat. That's it takes a param amount. I'm missing something inside. Okay, it seems to be param msat. Where we have it, yes, in JSON param, this is param msat, so this should work. Okay, so now that part, we want to return something. Maybe we want something to return. JSON. We removed everything, so okay, this is this one. So JSON add amount msat. We pass it the JSON stream. Now the field name, this is amount m millisat, and what's cool, the last part, amount msat, so we have to pass it msat, which is the scribe val, but no, this is m satoshi val, but as this is defined as a pointer to amount msat, we do that like it. Let's see if we wrote something that works. So while this is compiling, okay, please with a semicolon at the end. We spent already 1 hour in that live. I really want to end all the items that I wanted to do today. So if you don't mind, I will continue, I think, half an hour, and you can, if you have to leave, please leave, and you can watch it in another moment. Terminal. So we do again that L1 CLI stop, L1 CLI L1 dash start. So we restart with the binary, and the function that we call is that one. So both are required. So we are going to pass it both. Okay, we have amount msat, something that's cool because we used invoice, because we've used this one, JSON add amount msat. It understands if we pass it sat at the end or BTC. So let's check that. This is why it's important to use the right thing. So 10,000 millisat will be the same as 10 sat. Okay. And maybe if we pan 1 BTC, we see also what we get. So this is part correctly, and I won't give it a wrong answer, but we could. Almost done. So let's go back to the note. There's one thing left, is that the description, the second argument, we want to make it optional. Okay, so there is a macro to make it optional. This is at that point that we have to change something. This is when we set desk underscore val value. When we set that that variable, it's not required. So if we don't pass it, we don't want the macro here and the function param to raise an error. So there is another one which is called popt. Okay, and we pass it the same thing, and we see this is a function that we are using, param escaped string, but we could use param string also, but there is no reason to change that right now. And we're going to use it directly here, but we are not adding an amount millisat, we are adding a string. So let's add a string, so JSON add a string. And the name of the field is description, and now at the end what we pass it is a string desk val. So this should work. Let's see if this compiled correctly. Fine. We go into the terminal. stop, start it again. What are we going to do? I want this one, and we have it. Maybe we just change this for 20. I know. Sorry, what we want to test is, okay, so before I run that, so here, okay, this is optional, and I think that the thing that is happening is that when we are going to call that with a description val not being really a string with something but null, we are going to have an error. So I should have put if to test if we correctly set it. So now, if we pass nothing, so this should kill. Okay, so this is the error that I've done because I didn't check here, but now we can, as we know what we want to do, we can just check that. So if so, what do we check? So this is that. So if this is set, we can we add it. If it don't add the description. Okay, so now. Okay, please don't make typos. Okay. We go to the terminal, we stop that, we start it again, and what can we do next is let's do first that one. So this is working, and the one that didn't work is the fact that this was optional, and now we have something working with the parameter description, which is optional. Fine. So we've done more than the half of that live. That is taking a bit more time than I thought, but let's continue. I just take some a little break to drink. Okay, so now we've seen how. So let's go back to invoice to see what we've done. So we define a function that a command that doesn't take arguments. Now we did one that takes argument, one that is required, the other that is optional. We've used the function provided in the file param. Don't remember the file JSON param.c .h and c. We've seen that we have to initiate a JSON stream on the use function to add the field or array, and we haven't seen array. So now arrays. So we are going to see how to add arrays and to list the commands that are collected and are in the JSON RPC interface of the node. And we see just at the end, this is the auto data that does part of the magic. It's not magic, but this is the collection that's done. How? So now, let me think. We want to go in the JSON RPC.c. We are going to define it here, and we go at the top. And something that we can see, there are a bunch of commands that are defined here, and the L command. It's interesting to see how it is defined. We don't look at it, but we are going to define a function just after here. So let's go to peer, because we don't. We are going to copy that the first one that we used, JSON underscore foo. Go back to JSON RPC. We passed that here. Okay. And maybe we can do something to see that really we can't define two commands with the same name. So we compile that things. By the way, in the file JSON RPC.c, this is where the JSON RPC interface of Lightning D is defined. So, and now we go into the terminal to see that it's compiled correctly, but at runtime, so stop. And if we try to start it, it won't work because we try to define two functions with the same name. So cannot add duplicate command foo. Okay, so let's try to add this one in JSON RPC.c and the other one. So first things we do, we change that and we want to call it not JSON foo, but my comments, because we want to list a command. So why not? Up aligned. With this first we do with we change the name. It's no longer foo. This is my command, and we no longer call it foo here, but my command. So still we leave it into the developer category, and at the end it's cool. We are going to change the three commands that we built and put them the category CNN live, and we are going to see to list only the command with that category with the command my commands. But first, let's continue with what we are doing right now. So we still need the JSON stream. We take no parameters, so this is okay. We start JSON stream. At the end, we return something. Let's just compile that and try it to see if it returns the node ID, so that we can catch any error that we have we might have right now. Okay, so we do that. We stop again. Okay, yes, we start it, and L1 CLI my command. Okay, cool. So this is the third command that we define today. So we start to understand how to do that. So we go back here. What do we want to do? So let's go back to the note. We want to return something that has first argument its command, and then this is an array with the command defined in the JSON RPC interface defined in Lightning D. So when we start Lightning D, before entering the main function, there is a collecting of the all the functions that we define with autodata that are collected in some structure. So we're going to see that after, but in some map, and they are also put into the JSON RPC state of the JSON RPC interface, and this is what and then when the plugin system starts, I think, and if I remember correctly, it will add also all the command of the plugin. So when we the command that we are going to write list the plugin command and also the plugin set by autodata. If I'm wrong, please leave me a message or something. Reach out and tell me you're wrong. So let's go back here. And this is something that we have okay. First, let's keep this here. It's noise that thing. So we in the command we have the lightning. We have lightning. If we go to that one, we can see we also have the JSON RPC where it is. No, go to the lightning D struct, and we have it as a field that is a pointer to the JSON RPC. And the JSON RPC, this is the JSON RPC interface, the state where after that interface, we see that struct, okay, has a bunch of field. One of them is an array on the comments. So this is that one that we want to use. Okay, so what we do, we can do that. So struct command JSON. So we go back, we jump back. We are in lightning RPC, blah blah blah, and maybe I'm going to do that again. So we narrow. JSON my comments. We have that. Okay, we have the command. Let's set them here. So if everything is okay, so command, and we can have them with command lightning D. We see that we have the JSON RPC object, and in that JSON, which is a pointer, so we take the array command. Maybe that's it. So we have the array of the command, and we've seen those commands. Okay, so we have an array of an array of pointer on JSON commands. If we go to the JSON command, we have the name. So we are just going to list the name. We are going first to take one name. So JSON add string. So we want to add a string, and maybe the name will be a command. Okay, but first argument is always JSON stream command, the field name, and we want a value which is a string. And now we can use command. This is an array, and the first argument, the first thing will be a JSON command, and what we want now, let's see, pointer to a JSON command, and we want the name. So with that, we no longer want the node ID, and we should have the command. So we see here we get all the command in JSON RPC, and we take the name of the first command, and we put it in the response JSON string. Does it work? We see right now. So we compile. So just we see that we can. We hope that we can have the name of the first command in that array. If it works, after we're going to do a loop on all of them, and at the end we are going to do a filter to take only the one that is categories plugin, and then we change all the categories of the command that we wrote today to be still in live, and we are going to filter on them. Start again, and L1 CLI my command, and we see the first one is Ferret. So the first command that we get is Ferret. Okay, this is fine, and let's continue. So now we want an array. So to add an array to the JSON stream, we have, this is array start, or yes, this is array start. So we pass it response and the name, no, not the name, see, yes, the field name. So we are going to call it comments. We add that. Now we're going to add a buffer of string, but we don't want to have a field name. We just want the name. So to do that, when we use JSON add string, instead of putting a name to that field, so a field name, we pass it null. So this will just put the name of the command, and we still have to array end, and the response is that. Okay, so interesting, but we right now we are not looping. But let's see if we up. It won't work because I forgot the semicolon. So let's do it again. And but so we see we're going to have one array with one thing in it, which should be maybe if it should be a few rate. I think so. The compilation is okay. Yes. So terminal. We stop again. We start. And we have one field which is command, and we have its value is an array with only a few rates. So now we want to loop over this. So we have the array. Not that if. What is no, this is not a if. We are not filtering right now. For size, so we want the size to I, and I equals 0, and we want, what do we want? One interesting thing is that we want E to be strictly inferior at the size of the array. So in if I'm not wrong, so in core Lightning, the memory management is done by the module tal. So we can jump into tal count, and we see in the mod line. So we are in the file secant tal.h, and this is how the allocation of memory is done with the object. And in the case of the array, if it has been defined with tal underscore ARR, we can have the number of elements of that array. So this is really handy. So we can see here all the functions that are defined in that file, and we see here the macro. No, all the macro. Sorry, not all the functions that are so tal are. So we can have the count of the comments. I++, we have this, and now we don't add only the first one, but we loop over all. So it's command E, I, and we take the name. So this should work. Should work. So, yeah. So it seems to work. It seems to work. It's compiled. There is a it's not the same thing. So we restart Lightning D, and we call my command, and we see that we find a way to list all the commands defined Lightning D, and we see that we have some that are a part of Lightning D or other daemon, I think, and the ones that are from plugins. So, for instance, RunePay, is from plugin. We have this here. We have also pay. From a plugin, we have plugin SQL, and we also have our command foo, and maybe the two, one, we have my command, and if we go there, we also have my invoice. Okay, let's filter on the category. We are almost done, and this is cool. We know with an array. Okay. This is what we have. Okay, so we just want to filter on the category. So if that one, so category, that name is no longer name what we want. What do we want? We want, sorry, what do we want? We want the category. Okay, so we want the category. We want to check that this is equal. So in the CCAN module, there is a module for dealing with strings, so we can use it as a string ec, which compare two strings. So if that string, the category, is equal to the category plugin, we want to add that. So string x, yeah, I'm not wrong, should have been added at the top. It is already there. So sorry, I did. I don't know what why I did that, but it is in second. So I will narrow again this. So we loop, and if the category of the comment of the ith element is plugin, we add it to that array. Let's compile. Just a look quickly. Normally, I did not make any. Yes. Okay, so this is include stuff. So what I did wrong? I don't remember. I should have CCAN str, because I don't add it. So let's do this again, maybe. Str egg. Okay, so because I used to add it with the editor, and it has been added here at the top. So there is a rule, I don't remember, but those files are normally comes in alphabetical order, so maybe it should have to put this somewhere else. But anyway, we're going to use it like that. But remember that there is an order, and I think maybe it is enforced it is enforced with the CI or something like that, or in some way. But now we have that module here. So the function str equal. Okay, so I will remove this one. Okay, we see. at why it was just okay. So let's see. Now that we've taken so much time to do that, we're not going to stop at that point. Sorry, so compilation. So I will try a little bit, and if I okay, so maybe I shouldn't have removed this one. Let's look at JSON RPC. What have been done? Okay. So my bad. So .h is better. So this is the so a bunch of things have been installed by the LSP that I'm using, the language server. And let's go back to this one. Normally, but no, the .h is my fault. So, and I hope right now this is going to work correctly. Yes, so it seems to work, but let's go back here. We were again. We narrow, and this is what we did. So sorry for the last moment. Maybe I've started to be tired. 1 hour and a half, and so we use a string egg to check if the category is plugging. So normally, if we restart, start again, and now it should be. We have left. So right now we don't have all the comments. So before we have those one, but okay. So if we search for foo, we won't find it because it is no longer there, and we filter on the command that have the category which is plugin. So this is those one, but. Now let's do the last thing. So I'm not saying that this should be done inside. If we look at the notes, this is really the last thing that we do. The plugin commands. Okay, so this is almost done. But the command category, this is something that has been added in v0.7.1. And this is a category expected when inside the Lightning repository, and when this when this is not a plugin, and plugin can add any other category can be set by a plugin. Let's say we are going to set it to CLN Live, so that we can have them. Filter by CLN Live. So we change, we no longer filter the category by plugin, but by CLN Live. And we have to change that in all the command in the second argument, the second field. So CLN Live, we go to invoice. Let's go here. It's no longer category payment, but CLN Live, and the first one is what the function, the command foo, no longer developer, but CLN Live for the category. We compile again, and if it works, this should be the last thing that we do today, and which is a listing command that have the category CLN Live, which are the command that we defined today. So stop. We restart Lightning D. We call my commands, and we just have the free command that we defined today. So that's it for today. I hope this is useful, and it is clearer how to deal with with the definition of commands on some aspect of the Lightning repository with that live. I think there is no question on. We take a lot of times. Thanks for attending, you all, and see you in 2 weeks.